Good morning. I am K. Palnivel, Assistant Professor of Mathematics, SNS College of Technology, Coimbatore. Today, going to the topic Z-transforms and difference equation convolution theorem. Already see the last video in Z-transforms and difference equation partial fraction method, inverse Z-transforms also. Now see the convolution theorem. First, going to the definition of inverse Z transform. If Z of f of n equal to capital F of Z, then small f of n is called the inverse Z transform of capital F of Z and is denoted by f of n equal to Z inverse of f of Z. F of n equal to left hand side Z going to right hand side, there Z into Z inverse of f of Z. Next definition, convolution theorem. If capital F of Z and G of Z are the Z transforms of f of n and G of n respectively, then Z transform of f of n into G of n equal to f of capital F of Z and G of Z, f of Z into G of Z, where f of n into G of n is defined as the convolution of f of n and G of n, given by f of n into G of n equal to summation k equal to 0 to n f of k G of n minus k. Proof. This one is the statement of the convolution theorem. F of n into G of n equal to summation k equal to 0 to n f of k G of n minus k. Proof. We have f of z into G of z equal to summation n equal to 0 to infinity f of n into z power minus n, summation n equal to 0 to infinity G of n into z power minus n. F of z into G of z equal to f of 0, f of 1 z inverse, etc. etc. plus f of n into z power minus n plus etc. etc. G of 0, G of plus G of 1 into z inverse plus G of 2 into z power minus 2 plus etc. etc. G of n into z power minus n. Therefore, summation n equal to 0 to infinity f of 0 into G of 0 G of n plus f of 1 into G of n minus 1 plus etc. etc. f of n into G of 0 into z power minus n. Summation n equal to 0 to infinity a n into z power minus n. Therefore, where a n equal to f of 0 into G of n plus etc. etc. f of n into G of 0, summation k equal to 0 to n f of k G of n minus k in equal to f of n into G of n. This one is the convolution theorem of the equation. Next one, f of z into G of z equal to summation n equal to 0 to infinity a n z power minus n. F of z into G of z equal to z of f of n into G of n. We are going to see the one convolution theorem problem. Inverse Z transform using convolution theorem. Using convolution theorem to find Z inverse of Z square by Z minus A into Z minus B. We know that Z of A power n equal to Z by Z minus A implies Z inverse of Z minus A equal to A power n. F of Z equal to Z by Z minus A and G of Z equal to Z by Z minus B. Z inverse of f of Z into G of Z equal to Z inverse of capital F of Z into Z inverse of capital G of Z. Z inverse of Z by Z minus A into Z inverse of Z by Z minus B. Therefore, Z inverse of z square by z minus a into z minus b equal to a power n into b power n. Summation k equal to 0 to n a power k into b power n minus k. So simplify this one, b power n into summation k equal to 0 to n a power k into b power minus k. Therefore b power n equal to summation k equal to 0 to n a by b whole power k. b power n equal to 1 plus a by b plus a by b the whole square plus etc a by b whole power n. Simplify this one, b power n into cross multiply and eliminate this one. Finally we get a power n plus 1 minus b power n plus 1 divided by a minus b. This one is the solution of this given equation. Thank you.